Welcome once more to this class, and for a brief recap on our last class, I want us to throw small light on some examples on general gas equation and ideal gas equation. Alright, let's start with general gas equation. Now, I have an example here which says a gas which occupies 500 centimeter cube at STP. Remember, STP is standard temperature and pressure. And from our last class, we noticed that standard temperature is 760 millimeter and standard pressure is 760 millimeter mercury, and standard temperature is 273 Kelvin. So a gas occupies 500 centimeter cube at standard temperature and pressure. Now you see this is the volume and this is the temperature and pressure. So we need to know it. What is the pressure if the gas at the pressure of the gas at minus 48 degrees Celsius if the volume is reducing to half? Okay, this question is kind of, let's say, enclosed. You have to open it up. Now, the volume is reducing to half. Now, they gave us the first volume and they say reducing to half. Once they say reducing to half, I know 500 divided by 2, which is 250. So, you should know that minus 48 degrees Celsius, you need to convert to Kelvin. That means you need to add minus 48 plus 273 to convert to Kelvin. Okay, so we have our T2 and our V2, but they're asking us to find the second pressure, which is P2. So let us solve it. This is our formula for general gas equation, which says P1 V1 over T1 equals to P2 V2 over T2. Now, our P1 is 760, which is standard pressure. Our P2 is what we are looking for. T1 standard temperature 273 Kelvin. Our T2 is minus 48. So if you press your calculator, you see that minus 48 plus 273 will give us 225. Now, if the volume is reducing to half, that half of the volume is 250. So I have V1 500 and I have 250. So let's put it into the figures we have here. So I have P1, V1, T1, T2 all over V1, T2. How do we get it? We just cross multiply and make P2 the subject of the formula. If we bring up P2, what is remaining is V2 and T1. Okay, so we have P2 equals to P1 V1 T2 all over V2 T1. So we put our figures 760 times 500 times 225 all over 250 times 273. If you press your calculator, you see that it will give you 1252.7 millimeter mercury. How will you press to get this? Don't go and press 750 times this times this times this and do divided by 250 times this. You give another thing. Calculate this thing out, calculate this one out, divide the two. Calculate 760 times 500 times 225 out, you write it separate, and calculate this out, you write it separate. Then divide the two, then you get 1252.7 millimeter mercury. If you didn't do it that way, you get another reading. Okay, now that's it for general gas equation. Let us check an ideal gas equation. Here we have a question that says a given amount of gas occupies 10 dm³ at 4 atm and 273 degrees Celsius. Calculate the number of moles. Now they're asking us to calculate the number of moles. Now, if a given amount of gas occupies a volume of 10 dm³ at a pressure of 4 atm and temperature of 273 Kelvin and Celsius, we need to know all those things. Once you see atm in ideal gas, that means it's pressure. Remember, I tell you, it's only an ideal gas equation, that is where pressure will be defined by atm. The unit of pressure will now change from millimeter mercury to atm. Okay, all right. Now they gave us the relative mass constant as gas constant as 0.082 and it's already there. So we have the formula to be PV equals to nRT. That's the formula. P is 4 atm, V is 10 dm³, N is what you are looking for, N is the number of moles, T is temperature 273 degrees Celsius, which is 273 plus 273, which is 546 Kelvin. So I have R, which is here 0.082. So let us put it down. We cross multiply, making n the subject of the formula. Now, to make n the subject of the formula, we divide the both sides by RT. If you divide RT, now RT will cancel this RT, then it will PV RT equals to PV all over RT equals to n, which is the same thing as this, n equals to PV over RT. Okay, now which is 4 times 10 all over 0.082 times 546. If you press your calculator, you will get this. If you approximate this, it will give you 0.90 mole. There is nothing that the questions of this ideal gas and general gas equation does not pass beyond this border. It does not pass beyond this border. People are following. It does not pass beyond this border. So we are going to the ones that I know that yes, we need more classes to tackle them. We are going to those ones. When we get to that bridge, I pray we'll cross over. Alright, I think that is all you need to know about general gas equation and ideal gas equation. Let us go to the main thing. Today's class, we are going to talk about chemistry, and we have many topics. We have under gas laws that we want to talk about. We want to trash gas laws and give it let's do justice to gas laws so that we'll stop there and get to other things we need to talk about. Okay, so that we have talked about Charles law, Boyle's law. I've talked about ideal gas and general gas equation. Now let's talk about Danton's law of partial pressure. Now, Danton's law of partial pressure states that the pressure of gas that are not chemically joined together, that means gas that have not mixed, but they are inside a particular vessel, that the pressure of the two gas is directly proportional to the volume of the two gases. So now we talked about the volume of the two gases. Now when we look at the pressure, we know that the pressure of a gas it means that the pressure of the gas 1, gas 2, gas 3 all mixed together is the total pressure lies on the addition, let me say the sum of the 1, 2, 3 gases. Alright, let us look at this formula so that we understand what that formula is talking about. So that total pressure equals to pressure of gas A, pressure of gas B, and pressure of gas C. Now this is the total pressure. Now the partial pressure of one gas is equals to number of moles of the gas, of that particular gas, all over the total number of moles of that particular gas present in the mixture. What do I mean? Okay, now if you look at, let's see, I mixed 3 gases together and I'm having, okay, let's say gas A, gas B, and gas C. These 3 gases together, and I want to find, now maybe this gas is 5, this gas is 4, this gas is 3. Now I want to find one of these, so I'll have to find number of these, which is 2 over, let me say, okay, 5 rather, over 5 plus 4 plus 3. Hope you understand. That means the partial pressure of one, I will find it inside here. The pressure of this one, I will use the number of moles present to find it. Now, if 5 plus 4 plus, so that will give us 12. Now, this one 5 over 12. If you check, it will give us one whole number. Let me say one whole number, 2 whole number 2 over 12. 2 whole number 1 over 6. In the fraction. Now, this is just the partial pressure for this particular gas A. We can do it in other ones. Hope you are following. Okay, that's that for partial pressure. I just want to explain what that particular thing is talking about. Now, when we have the total number of moles in gas A, the number of moles in gas A divided by the total number of moles in the mixture, now we times it with the total pressure. Don't worry, one of these questions we will see what we mean. Now, this thing also means PA. This is partial pressure. Mathematically, this is what it means. number of moles of A, all over number of moles of A plus B plus C times pressure, that's total pressure. Okay, without wasting much of time, we will go and check one particular example. I found that example very intriguing. I just brought it down here so that we will use it to dialogue and know. Like I said, I have a question here in partial pressure, and I want us to go straight to it. Pardon my, but we will just follow the step. Just follow me. Follow me. Yes. Okay. So we have a question here that a closed vessel contains 2.8 grams of nitrogen and 14.2 grams of chlorine at standard temperature and pressure. That particular standard temperature and pressure came again. Now, when I was in school, I remember I had this problem of not knowing when to apply this. Please, I know why I'm sensitizing on it so that you will not fall a victim. Alright, now the question says calculate the partial pressure of the nitrogen if the temperature is raised to 180. Now they are asking us to calculate the partial pressure of only nitrogen in a mixture of nitrogen and chlorine. Okay, so let's go down. First of all, they gave us only one pressure, but they didn't give us the second pressure, which how can we get it without knowing the second pressure that it gets to when the temperature is raised? We need to get the second pressure, and that is the total pressure. Okay, now how to get it? We use our gas laws. We bring down a general gas equation. Now, since we have volume, isn't it? We have volumes of 2 chlorine and we have volumes, but we have volumes, we have pressure 1, pressure 2, and we have temperature 1 and temperature 2. But the volume is just a constant volume. It doesn't change. So volume is constant. So since the volume is constant, we'll take away the volume and we'll just use only pressure and temperature. So PT over PT, P1 over T1 over P2 over T2. Now we make P2 the subject of the formula and we have this. So we impute our parameters, which is P1, first pressure in standard temperature and pressure is 760 millimeter mercury, standard temperature 273, partial pressure, which is P2, is not there. Remember, it is pressure. With this partial pressure, calculate pressure of just pressure. Let's be sure of the pressure. That is best. Find the pressure first. This is where we calculate the total pressure before we talk about the partial pressure. I will follow you. Now, pressure of the hole. When the temperature is raised, that's the P2. It was not given, but the temperature is raised to 180. So 180, we convert it to Kelvin, which is 453 Kelvin. Alright, let us put that parameters there. They have 760 times 453 all over 273. If you press that in your calculator, you have 1261 millimeter Hg. Automatically, that is your total pressure. Once you have that, that is your total pressure. But they are asking us the partial pressure of nitrogen. But the partial pressure of nitrogen equals to number of moles of nitrogen all over number of moles of nitrogen plus number of moles of chlorine times total pressure, which is 1261. Are we following? Now we move forward here. Now 2.28 is the volume of nitrogen all over 28 grams, which is 14 times 2, any 2. Good. Now the next one is all over number of moles, which is this, plus that of chlorine, which is 35.5. 14.2 all over 35.5 times 2 is Cl2 times 2. It gives us 71. So if you press your calculator for this, you get 0.1. Now 0.1, you press your calculator, you have 0.2. I hope you have seen it. So with that, if you press 0.1 divided by 0.3, this is 0.3. 0.1 divided by 0.3 times 1261, it will give you 420.3 millimeter mercury. That is your answer for this question. Just follow me gradually as I rephrase it. So let's go back. If you understand this question, this is the formula for it. So the question says an enclosed vessel contains 2.8 grams of nitrogen. Only nitrogen. Not only nitrogen. And also have 14.2 grams of chlorine. So at standard temperature and pressure. Alright. Remember I told you, don't fall the victim of not knowing your standard temperature and pressure. Temperature is 273 Kelvin, which is 0 degrees Celsius, while your pressure is 760 millimeter mercury. Okay, now calculate the partial pressure of nitrogen. The answer is to calculate the partial pressure of nitrogen. Finally, that is what we will do finally. But at first, we will get the pressure as a general, as a gas. We get the pressure as a gas before we talk about the partial pressure. So the pressure of nitrogen, if the temperature is raised at 180, so let's find the temperature first. So we put our formula of general gas equation, but the volume is constant. The volume did not change, so the volume is constant. So we take away the volume, moving pressure and temperature. So P1 over T1 equals to P2 over T2. If you cross multiply, you have P2 equals to P1 T2 over T1. Right? So if we impute our parameters, we have 760 times 453 all over 273. If you press that in your calculator, like I said, you have 1261 millimeter mercury, and that is your total pressure. That's the first thing to find. Total pressure. Pressure 2. Total pressure. Remember that the first pressure is this. The standard temperature 760. Now, when the temperature increased to 180, another pressure was given. That pressure that was given is 1261 millimeter mercury. Hope you are following. Now, this one is your total pressure. Just in case you have a similar question, you know how to just impute, solve. Note the one that in either they put temperature changing, but they will give you. They have to make it in a way that it will be balanced. They will not give you an unbalanced question. Alright. So once you do it, what you do now is you take away the volume, cross multiply the rest, you have P2 equals to P1 T2 over T1. Impute your parameters. Press your calculator. You have 1261, which is your total pressure. Now, but we want to calculate the partial pressure. This is where we will now put down our formula for partial pressure. Partial pressure equals of nitrogen, which is Na2, equals to number of moles of Na2 all over number of moles of all the mixture, which is chlorine and nitrogen gas. So times the total pressure. If you check up here, you have 2.8 over 28, and if you check here, you have 2.8 over 28, which is for number of moles of N2 plus number of moles of chlorine, which is 14.2, which is the volume of chlorine, 14.2 divided by 35.5 times 2, which is 71. Chlorine is Cl2, that's chlorine gas. 35.5 times 2, which is 71. So if you press it, you have 0.1 and this 0.2. So if you press that 0.1 all over 0.1 plus 0.2, which is 0.1 divided by 0.3 times 1261. If you press that in your calculator, you have 420.3 millimeter mercury, and that is your answer. Alright, let us go to the next one, the Newton's law of combining volume.